Drug stability first. Chemical kinetic contains reaction kinetic, law of mass action, rate of reaction, molecularity of reaction, order of reaction, determination of reaction order. फर्स्ट वन रिएक्शन काइनेटिक, ये केमिकल काइनेटिक भी कह सकते हैं, और केमिकल काइनेटिक को आल्सो नोन एज रिएक्शन काइनेटिक, ए स्टडी ऑफ रेट ऑफ केमिकल प्रोसेस. Chemical kinetic is the branch of chemistry that is concerned with understanding the rate of chemical reaction. In 1864, Peter Ward and Cato Gullberg pioneered the development of chemical kinetic by formulating law of mass action. Law of mass action: the rate of chemical reaction is proportional to product of molar concentration of reactant, each raised to a power equal to number of molecules of the substance undergo reaction. Rate of reaction: the speed of reaction, speed or rate of a chemical reaction is the change in concentration of a reactant or product per unit time. Molecularity of reaction: molecularity is number of molecules or atoms that must collide to give product. Stoichiometric equation is essential to decide molecularity. It must be small number and cannot be fraction or zero. Molecularity of reaction: three type basic: unimolecular, which contain one number of molecules 1 or atoms 1. Bimolecular or I repeat, a unimolecular if number of reacting particles is 1, then the reaction is considered to be unimolecular. And bimolecular, when reactant molecules are involved, to carry out the reaction. These reactions are called bimolecular reaction. And when three reactant molecules are involved to carry out the reaction, these reactions are called trimolecular reaction. Order of reaction. Order of reaction is defined as number of concentration term on which the rate of reaction depend when determined experiment, or we can say the sum of exponents or power of concentration term in the rate equation is known as order of reaction. And the power dependence of the rate of reaction on concentration of each reactant. These are basically 5 types: zero order reaction, first order reaction, second order reaction, pseudo order reaction, and pseudo first order reaction. Zero order reaction: a reaction in which the rate does not depend on concentration term of reactant. For example, color loss of liquid multisulfonamide preparations, oxidation of vitamin A in oily solution, photochemical degradation of chlorpromazine. Second one is first order reaction, a reaction in which the rate of reaction depends on concentration of one reactant. For example, decomposition of hydrogen peroxide catalyzed by potassium iodide. Second order reaction, a reaction in which the rate depends on the concentration term of two reactant. each raised to the power 1. For example, alkaline hydrolysis by ester, hydrolysis of chlorbutamol, pseudo zero order reaction, a reaction which may be first order but behave like zero order depending on experimental condition. Example, suspension. Pseudo first order reaction, a reaction which is originally a second order reaction but is made to behave like first order reaction. For example, hydrolysis of ester catalyzed by hydrogens, base catalyzed oxidative degradation of pyridoxal pyridoxalone in aqueous solution, methyl water, acetic acid, methyl alcohol. Determination of reaction order. Graphic method, substitution method, half-life method, initial rate method, software tools. Graphic method. The kinetic experiment is conducted and data are collected on time course of change in concentration of reactant. A graph is plotted as per the general principle of each reaction order. Below say concentration of order and dx dt, concentration first order and concentration second order. A straight line that gives best fit to identify the reaction is considered to be of that order. Substitution method. A kinetic experiment is conducted and data are collected on the time course of change in concentration of reactant. Data are substituted in integral rate equation to get K value. The order which gives constant K value at different time period within the experiment is identified. The reaction is of that order. Half-life method. The half-life are calculated for each time period is kinetic steady.